questions?
Doctor,
Yep.
how do we know that the car is moving to north?
Oh, sebab soalan dia cakap ni. The car is moving north.
Oh,
Hmm.
right.
So soalan dia bagi. So that's why I decided UBX is 0. Macam tricky jugalah. Sebenarnya dia salah buat soalan. But tak apa. Kalau kita ada soalan tricky, kena tengoklah macam tu. Okay, is that okay?
Okay.
Can I know? Okay. Alright, so let's move on to our Rep Assign Chapter 4, number 10. I think everyone has done this or not, but let's just discuss it, okay? So a block of mass is a block of mass with mass of 3.2 kilograms is released from rest at point A. So from rest, the U is 0. 0, right? Let's just say V. Okay. V at point A is 0 and slides on a frictionless track. So frictionless means no non-conservative forces. No non-conservative forces. I don't know what's wrong with this tablet today. Ayo. Kenapa lah ada benda-benda ni? Okay, conservative forces. Which means that if there is no non-conservative forces, your E initial should be equal to your E final. If there are non-conservative forces such as friction, heat, sound, etc., your equation becomes EI minus W and C equals to EF. Okay, but because there's no non-conservative forces such as friction, our equation is simplified, which is EI equals to EF. But in real life scenario, that's not possible. Okay. Assume HA is 6.7. Okay. So this guy is 6.7 meters. Okay. Determine the block speed at points B and C. So it's asking you what is VB and what is VC. Okay, so using this conservation of energy punya equation, we know that we have a bunch of terms such as KE initial, UG initial, UE initial, minus WNC equals to KE final plus UG final plus UE final. Okay, this is your basic equation. Now, the energy that's not in this situation is elastic, it's not there. Okay, and WNC is also not there. So now you are left with KEI plus UGI equals to KEF plus UGF. Okay, how did I know that there is UGI and KE? Okay, so when you drop this block of mass, there is a change in height, right? When there is a change in height, we always have MGH. We always have the change in U, change in potential energy. And then how did I know there is kinetic energy? Because obviously it's moving and the question says is asking you for speed. So that's your big clue. Okay, so this is my equation that I'm starting with. Always, first of all, this is your first equation. Oh wow. Betul lah, I rasa macam ada the sensing thing is not working today. Okay, so you start with this equation, identify what are the energies. Yes, what are the energies in the situation? Question?
Kenapa 11? Kenapa start dulu?
Question? Ada? Okay. Siapa tu? Tak nampak iPhone. Siapa iPhone ni? Who is iPhone? Okay, so let's continue. So this is the equation that I get when I have identified the energy in the situation. So now I'm gonna plug in. The mass is 3.2. Okay, tak apa, kita tulis equation dulu. 1/2 m v A squared plus mgh initial equals to, what is my final here if I'm looking for my B, speed? What is it? No one? Okay, let me re-explain this. Okay, possibly this is not very intuitive. Okay, so now I said EI, based on the conservation of energy, your EI should be equal to EF, right? Which means that the energy is conserved throughout when the mass glides over this track. So basically it's saying EA is equal to EB, the point at B, equals to EC, the point at C. The energy does not ever change, which means that if EA is 200, EB is 200, EC is 200. It doesn't matter if the velocity decreases or increases, the energy is the same, it's constant because tak ada friction. Okay, so based on that information, let's calculate for the energy at EA first. Okay. Okay, korang ni ngantuk ke? Or just panicking inside? Okay, so let's calculate for EA. So EA has kinetic energy. Does it? It starts at rest, so it's a 0. Does it have potential energy? Yes, because it is at a height h. So mgh. Okay, how did I know KE is 0? Because it starts from rest, which means that VA is equal to 0 and KE is dependent on V. Okay, mass is 3.2, 9.8 times height. Height is 6.7. And if I'm calculating this right, this is 210.33 joules. Okay, so your EA is 210.33 joules. Now the mass slides over to point B. What is the energy? The energy is the same. It's equal to EA. But now it has velocity, which means that if my KE increases, I have to take some of the energy from mgh, right? So my mgh decreases to make this equal to EA. Okay, so let's calculate that. Here, the energy from mgh is transformed into kinetic energy to give the block of mass velocity. Okay, so EB is 1 over 2, 3.2, the velocity at point B squared, plus mgh. mgh, m is 3.2, 9.8, 1, and the h at point B is 3.2. So now there is a decrease in potential energy, which is transformed into kinetic energy. Why? Because energy is conserved. Whatever happens to mgh or ke, the energy must stay 210.33. Kena, wajib. Conservation of energy punya rule. Okay? So now, using this equation, we can calculate for our VB. So VB is 8.29. Oh, kat situ dah ada. 8.28. Okay, lebih kurang lah. Errors in decimals is common. So 8.28 meter per second. That is the velocity at B. And if you know already for B, if you already know how to solve for the velocity at B, you will know how to solve for C. Same thing. If EA is equal to EB, it should also equal to EC based on the conservation of energy. No matter what happens to mgh, no matter what happens to the velocity, the E should always be constant. Sebab tak ada friction. Kalau ada friction memang jadi susah lah soalan ni. Okay, and then so EC is also equal to EA equals to EB. Okay, which is 210. So the equation for EC is, saya cuba tempat lah pula, 210.33. Okay, let's do this on another slide, new slide. Okay, so EC is equal to 1 over 2, 3.2, sorry, 1 over 2 mv squared at point C plus mgh at point C. So this becomes 1 over 2, 3.2, VC is, we don't know, squared, plus 3.2, G is 9.8 times H at point C. So that's a 2. So the MGH has further decreased because the velocity increases lah kot. We don't know. But possibly the VC is greater than VB because the energy from the MGH is further transferred to your KE. Okay, so now EC is 210.33, which gives us a VC as berapa lah? Tak kira kot. What is VC at? Oh, kat situ, 9.6. Betul lah. Dah ada jawapan dah. Okay, so 9.6 meter per second. So because the height decreased, it has to convert the energy into KE, which makes the velocity higher. Okay? So that is for the velocity. Determine the net work done by the gravitational force on the block as it moves from point A to point C. So net work done is equal to the change in energy. We know this already from chapter 4. Okay, so from here, we know that there is a change in kinetic energy and there is also a change in mgh. Okay. So we can calculate for the change in energy based on KE boleh, or based on MGH pun boleh juga, UG, because the change will be the same. Okay, let's try this. But here is asking you for gravitational force. So let's buat gravitational lah. Okay, so here, determine the net work done by the gravitational force on the block as it moves from point A to point C. Okay, so this is your gravity. W equals to mg. Okay, so work done is also equal to F cosine theta d. What is the displacement in the direction of gravitational force? The displacement in the direction of gravitational force is just height. Are we concerned about what happens during the glide? Not really. We just want the displacement in the y direction. So in the y direction, we know that there is a change from 6.7 to 2. Okay, and W, work done, will always have a change. To find the work done, we need to find the change in energy. Okay, so here my F is just mg because it is the force of gravity. And cosine theta means the angle between the force and the displacement. And since we are only concerned about the displacement in the direction of gravity, that displacement is just a change in height, which is just mgh. Okay, so this becomes m is 3.2, g is 9.8. Okay, what percent pakai 9.8? And the change in h is 6.7 minus 2, which is berapa tadi? 6.7 minus 2.
4.7.
Oh, 4.7. Thank you. Okay, so this becomes berapa eh? Mana tahu saya punya nota? Oh, saya tak kira. Ya, ada. 147.39. Betul tak? 147.39 joules. Okay.
Doctor,
Yep.
I got 1.7.54.
1.7. Oh, 54.
0.54.
Oh, okay. Saya rasa ada beza. Kenapa? Oh, maybe saya salah tekan calculator kot. Tapi equation ni betul kan? 3.2 times 9.8 times 4.7 ni sama kan?
Sama.
Okay, saya salah tekan kot. Or saya salah tulis. Sure. 57 eh? 57. Thank you.
5-4.
Oh, 54. Thank you. Okay, so now you're asking me, Doctor, should the MGH be positive or negative? Okay, remember if it is in the same direction, work done is positive. If it's in the opposite direction, work done is negative. Now the displacement is going downwards, right? It is moving downwards and our force of gravity is also moving downwards, which means that the work done is positive. Okay. Okay.
Doctor.
Yep.
Just now your answer is 147.39, right? It is because your G is 9.8. If you write 9.81, then you get 147.54.
Oh, okay. Tapi kalau web design pakai 9.8 kan?
Oh, So it is still correct kan?
Correct je, sama je.
Alright.
Okay, any questions about this one? Faham ke?
Faham.
Faham Yang EA equals to EB equals to EC tu faham Okay. Okay, so our last discussion on potential energy. Oh, gambar saya hilang. Sekejap. Gambar apa ni? Sekejap, cari balik. Oh, gambar ni 5 and 10. Okay lah, saya lukis balik je lah. Kenapa saya ingat? Okay. Boleh dah. So this is 10. Okay, and then we have a ball falling down. This is 10. This is 5 meters. This one is also 5 meters to ground. Lagi. Okay, 7. Okay, so here both of the mass are 1 kilogram and one is falling downwards by 5 meter. So it starts from a height of 5. Whoopsie. It starts from a height of 5 and falls down to the ground. Okay, this one is 5. Falls down to the ground at h equals to 0. This guy falls from a height of 5 and falls down to a 0, but it is on an incline. Okay, so my question to you is, what is the energy in both balls at the start of before they are thrown, before they move? What is the energy of both balls? Anyone wants to guess?
Gravitational potential energy.
Okay, gravitational potential energy. So MGH, let's try that. MGH is 1 times 9.81, 1 times 5, and this guy should also be the same. Okay, so that is 1 times 9.81 times 5. Okay, now my question is, okay, first question tadi is initial energy of both balls. Okay, number 2, the question number 2 is, what is the work done by gravity? Okay. So work done by gravity for the first situation A versus situation B. Okay, so situation A, the work done by gravity is easy. We know that the displacement is going down, right? And our displacement is just 5. Kenapa lah? Our displacement is 5. Okay, so work done is F cosine theta D, and our F is just mg, and our cosine theta, the angle between displacement and the force, is 0, so this becomes a 1. The D is our displacement, and it's going down in the same direction as the gravitational force, so that is just mgh. That is the work done. Okay. Delta H, work done always change in energy, right? Change in energy. Lepas tu baru dapat 5. Berapa tadi? Mass is 1, 9.8, and H is 5 minus 0, which is also mgh. So that is the work done by gravity. What is the work done by gravity in this case? For this guy, for this ball. Work done is F cosine theta D, and we know that the displacement of this ball is 10. So how do we do this one? The displacement of the ball is 10 in this direction. Any guess? The displacement of the ball on the incline is 10. So how do I calculate for work done? No guesses? More confused dah. Nak kira ke bawah ke nak kira ke atas incline? So here actually there's two approaches to solving this. You can calculate you can solve it with respect to the force. You can also solve it with respect to the incline displacement. Jawapan dia akan sama. But eventually you will reach the same point. Okay, energy is conserved. If you end up at the same point and you start with the same energy, it's going to be the same no matter what happens along the way. Okay, assuming tak ada friction lah. Okay, kalau ada friction and it's a bumpy ride, then you lose a lot of energy. Okay, but anyways, I'm saying if you solve it with respect to the incline versus you solving it with respect to the displacement in the y, the answer will be the same. Okay, let's do this one. So let's solve it with respect to the incline first. So solving with respect to the incline, which means that I have to resolve my mg in this direction. Betul tak? I'm only concerned about the parallel components. So my displacement and my force needs to be in the same direction. Okay, let me use a different color for that. Confuse-nya tengok. Let me use pink. Okay, so this guy is mg. The component that is parallel to my displacement on the incline is, this is a theta. So this becomes mg sine theta, right? So the parallel component is mg sine theta times h times the 10. So now they are both in parallel. Mg sine theta is parallel with 10. So now I can calculate for work. Work always wants to be parallel. Okay, so m is 1, g is 9.8, sine is 30, and 10 is just 10. Sine 30 is 0.5. 0.5 times 10 is 5. 0.5 is 1 over 2, right? Basically 1 over 2. So you just divide 10 by 2. So this becomes 159.81. Sama tak?
Sama.
Yes, it's the same. Even though I solved it using an incline. Now, if I said, tak naklah solve pakai incline, nak solve with respect to the force going down. Which means that I need to use my mg in full force. Tak ada sign, tak ada apa. It's mg, 100% mg lah. So if I were to solve it like that, my w becomes f cosine theta. This is my just equation for work. But mg, the displacement that is parallel to mg is height. And the height from this point to this point, I know what it is, it's 5. So the displacement in the direction of gravity is 5. So mg 5, which is sama juga. Okay, so here it's important to know that the change in energy is the same. Okay, no matter what happens in between, no matter how you try to solve it, it should be the same. Okay, so remember, work done, you always try to solve it in parallel. You can solve it in parallel to the original displacement, or you can solve it in parallel to the original force. If not, you have to resolve your force in displacement or resolve your displacement in your force. Here, what I did was I resolved my displacement in the y direction. That is what I did. But I already gave you the 5 meter, so that's why I did not resolve it. But if I were to have to resolve displacement in the direction of force of gravity, so how would I do that? So this becomes a 30, tak nak fikir pula. So this is 10, right? This becomes 10 cosine 30. So tak? This becomes 10 sine 30. Sine 30 is 0.5, basically 5. So sama je. I resolve my displacement with respect to be in parallel with my gravitational force. So that is what I get. Faham ke? Okay ke? Faham Okay. One more thing to go. Sekejap. Ini susah sikit nak cerita. Taking a deep breath. Okay. How do I explain this in a way that you guys will understand better? Sekejap. Okay. No questions for me so far? So everyone's okay? Sekejap. See my phone. Sekejap eh. Foto. Where is it? Okay, dah ingat dah. The table. Wow, cantik pula saya lukis. Okay, lepas tu, this one is ada block of mass. Oh, bukan block of mass ni, egg. Tak apa. So this egg is lifted off the table by 0.45. The mass of egg is 1.5 kilogram. Okay, so now the question is asking you, sorry, this is a diagram, and the egg is 1.5 kilogram. It's an ostrich egg. Okay, don't question why it's 1.5. Okay, it's lifted off from the table by 0.45 meters, right? And it is lifted off from a table of height 0.85. All right, so that is your situation here. And then it's asking you, what is the change in gravitational potential energy of the egg? So how do you solve this? What should you do? Okay, so it's asking you for change, right?
both height.
Apa?
Calculate for both height.
Calculate for both heights and betul tu step tu. Lepas tu
Subtract.
subtract. Okay, let's try that. Syakirin yang tadi, thank you. Okay, so Syakirin said calculate MGH for both heights and then subtract. Okay, let's try that. So my H is my H is 0.85 meter, and the H over here is, kejap oops, sorry, that was loud. There's a gravitational potential energy of the egg. Okay, this is equal to 0.85 plus 0.45 meters. And then Chakrin said calculate for the MGH here. So UG here is M 1.5 times G 9.81 times 0.85 plus 0.45. And the UG over here is 1.5, 9.81, and 0.85. Okay. Now, would it be the same if I said I started with H equals to 0 over here and H equals to 0.45 over here? Would the answer be the same? Would the answer be the same? Yes. Why would it be the same?
Delta H is
Kenapa?
0.45.
Sebab the change is 0.45. So the height of the table does not matter? Does it matter or not?
No.
No, okay. Tapi when we are on top of a table, we already have some potential energy. Kenapa tak penting? Tak ada jawapan dah. Sebab kita nak cari change je. We are only asking for the change. So when we are asking for the change, we can actually label our reference point as 0, which makes our life so much easier. And I love it when my life is easy. So let's just label our reference point 0. Y equals to 0. Oh, height, sorry. Tapi height equals to 0 macam pelik kan? Let's buat Y lah. Y equals to 0 and Y equals to 0.45. Why can I label this as 0? It is my reference point. Reference, yeah? Bukan in real life, it's not 0. We know that. But it is my reference point to find the change. So to find the change, delta Y is just 0.45 and it's easy. So now I don't have to minus the 0.85 with this guy, which is also the same thing. So this is UG final, UG initial. So you will get 1.5, 9.81 times 0.45. So that is the change when you lift up the egg. Okay. Apa saya nak tanya tadi lupa. Okay, so now my question is, what is the work done against gravity to lift the egg? This was number 1. Number 2, what is the work done against gravity, gravity to lift the egg by 0.45 meters. We have seen this before. We have seen the term against gravity. What does it mean? What does it mean? Work done
Opposite.
opposite
It's
of
negative.
apa? Negative. Apa yang negatif?
The work done.
The work done is negative. If I'm asking you what is the work done by gravity to lift the egg, yeah, then yes, work done is negative because gravity is going down, but the displacement is going up. But now I'm asking you what is the work done against gravity? Maksudnya terbalik dari gravity tau. Against ni tolak kan? Against ni macam nak cakap against. Against in Malay apa? Against.
Melawan.
Berlawan kot. Berlawan dengan gravity. Yes, thank you. Berlawan dengan gravity untuk to lift the egg. So here it's just mg delta h. It's a positive because we are not asking about work done by gravity. We are asking what is the work done against gravity. The work done against gravity is potential energy, which is why our mgh going up is positive. Okay, because it's going against gravity. Okay, faham tak? Faham tak? Confuse korang ni. Okay, kejap kita ada 10 minutes. Okay, let me try one more time. Another example. Okay. Tapi faham yang reference point tu? Is that okay with everyone?
Okay.
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 Okay. Okay. So I have a box on the ground. Okay. This is my box. It is on h equals to 0. And then I lift it up by a force. Betul tak? When I lift it up by a force, I am actually opposing mg. Betul tak? When I need to lift an object, I need to apply a force that is equal to the weight of the object, assuming that I am going at a constant velocity. Maksudnya saya tak adalah nak accelerate box tu. Saya bawa slow-slow je, bawa at a constant velocity, I'm lifting the object. Okay, so based on chapter 3, we know that, we know that we have mg. And there is r. Okay, it's on the ground. For me to lift the object I need to apply mg juga, so that I can move it at a constant velocity. So now, okay, ini just free body diagram. I am applying F applied to lift the object. Okay, ni common sense lah kan? Takkan tak pakai force kot nak angkat barang, betul tak? F applied to lift mass. Okay, common sense. You always need to use your force to lift an object. This F applied to lift the mass is actually going against gravity. Kenapa going against gravity? Because you need to apply an F that is equal to mg for your box to be lifted. If it's less than mg, your box won't go anywhere. Sebab berat kan? You need to apply mg or greater. So here I said constant velocity, so it's just equal to mg lah. My force, the force that I'm applying to lift my box is equal to the weight. And I'm going at a constant velocity. Okay, so far everyone following me? Setakat ni si borang kat kotak je. Okay ke?
Okay.
Yeah. Okay. So now the F applied to lift the mass going against the gravity, and then I go over a displacement by delta H from the ground, sorry. From the ground, I go displacement H, and then I reach this point. Okay, this is my hand lifting the box. Okay, oh cantik pula hand saya ni. Okay gak lah kan, selalu lagi teruk. Okay, so here I have delta H. So now the work done to lift the box is mg delta H. Why is it mg delta H? Because F applied times displacement in the direction of F applied. My F applied was mg, the weight of the box. Delta H is the displacement in the direction of my force. So the work done that I am doing against gravity to lift the box is mg delta H. That is the work done. Am I losing energy? Am I losing energy when I do work?
Yes.
Yes, penat kan? Angkat kotak, penat. Where does the energy go? It goes into the object in the form of mgh, positive mgh. The mgh that you are calculating is the force to lift the object from the ground. That is how the object gains the potential energy. Okay, from my F applied sebenarnya. Okay, does that make sense? I lose energy, that energy goes into the object. I'm doing work against gravity to lift that object. I am losing energy because I am so tired after lifting it, but that energy has to go somewhere based on the conservation of energy. The energy goes into the box as potential energy. Okay, but selama ni kita belajar, oh bila naik atas terus ada mgh. But before it gets that mgh, that is the process. There is a force that lifts the object, and someone somewhere is losing energy to lift that box, and that box to gain the potential energy. Okay, but as always, you always just need to know mg delta H. You don't need to know how or why or who is giving that energy to the box. You are only concerned in the mgh of the object because they are simplifying that situation for you. Okay tak?
Okay.
Is that more intuitive or more confusing? Lagi confused ke?
Tak.
Alright, so I'm glad. Okay, all the best with your assessment. I'll see you next week. Kita akan buat revision Alright, so bye-bye. Take care.
Thank you,
Thank you,
Doctor.
Doctor.
Doctor. Love you.
Thank you, Doctor. Have a nice weekend, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor. Have a great weekend.
Thank you, Doctor.